Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from partial differentiation, right? And here we are going to make use of the concept of total differential coefficient. And here we are given this problem where a function u is given as f of x minus y, comma y minus z, comma z minus x, and we have to find the sum of the partial derivatives of u with respect to x and with respect to y and with respect to z, right? So here u is a function of x minus y minus z, and z minus x, and we have to find this sum, that is del u over del x plus del u over del y plus del u over del z. So let us see how we can find out the value of this expression using the concept of partial differentiation and total differential coefficient. So now let us first consider the case where we have a function, say u, which is a function of x, y, and z, right? So here we are given a function u, which is a function of x, y, and z, and further x, y, and z are functions of a single variable, say t, right? So here we are given u as f of x, y, z, that is u is a function of x, y, z, and further x, y, and z are functions of some single variable t. So we can now write here x is a function of t, y is a function of t, and z is a function of t, right? So here we can now write the total differential coefficient of u, that is du over dt as del u over del x. Then we have here a dx over dt, and then we write here a del u over del y, and here we have dy over dt, and here we have del u over del z, and here we have a dz over dt, right? So here first we are going to develop the formula, and then we'll write the or we'll apply the formula to this problem. So here we are given u as a function of x, y, z, and further x, y, z are some function of a single variable t. Then du over dt is the total differential coefficient, and du over dt is defined by this expression, right? So here x, y, and z are given as a function of single variable t, right? Now let us consider the case where we are given a function, say u, which is a function of x, y, and z, and these x, y, z are functions of two variables. For example, here we can take x as a function of, say, t and r, right? So in this case we have considered that x, y, z are functions of single variable t, but now we are considering x, y, and z as a function of two variables, right? So here we have y is a function of t and r, and z is also a function of t and r, right? So now let us see how we can modify this expression when u is a function of x, y, and z, and x, y, and z are further functions of two variables, right? So now when x, y, and z are functions of single variable, then we have this expression. But when x, y, and z are functions of two variables, so let us write or let us modify this expression for t and r, right? So here we have du over dt, and x, y, and z are functions of t only, right? And here x, y, and z are functions of two variables, that is t and r. Here also t and r, and here also t and r. So let us modify this expression. So now we have to write here the partial derivative, right? So we'll write del u over del t, and then we'll write the expression for del u over del r, because here now we have two variables, right? So now for del u over del t, we can now write here del u over del x, and here we have dx over dt, right? Now here x is a function of two variables, so we have to replace these derivatives, that is d by dt, by the partial derivative notation, that is del over del t. So here we have del x over del t, and similarly here we have del u over del y, and here again d by dt should be replaced by del over del t. Here we have y, and then we have del u over del z, and here again d by dt is replaced by del over del t, and here we have z, right? So when x, y, and z are functions of two variables, say t and r, then here d by dt should be replaced by the partial derivative notation, that is del over del t, and we have this expression. And similarly here we can now write del u over here we have del u over del x, and here we have dx over dt. So now this t should be replaced by here r. So we have now uh, del x over del r, and then we have del u over del y. Here we have del y over del r, and del u over del z, and here we have del z over del r, right? So when x, y, z are functions of only one variable t, then we have this expression. But when x, y, and z are functions of two variables, then here we have two expressions. And similarly, we can extend this process for more variables also. So now let us extend this idea to three variables. Now suppose u is a function of x, y, and z, and x, y, and z are functions of, say, three variables. So here we have t, r, and we can also introduce here the variable, say, s, right? And here x, y, and z are functions of three variables, t, r, and s. And here we have s, here also we have s, and here also we have s, right? So now in this case we have three expressions, right? So here we can now write a del u over del s, right? So first we have obtained del u over del t, then del u over del r, and now we have to write expression for del u over del s. So here we have del u over del x, and here we can now write del x over del s, and here we have del u over del y, and here we have del y over del s, and here del u over del z, and here we have del z over del s, right? So now when u is a function of x, y, and z, and x, y, and z are further functions of three variables, t, r, and s, we have these three expressions. So now we are going to use this concept to solve this problem. So now let us take x minus y is equal to p, and y minus z is equal to q, and z minus x is equal to r, right? And here we can take p as a function of x, y, and z. Similarly, q can be taken as a function of x, y, and z, and here we have r is a function of x, y, and z. So now we can write this expression, that is u is equal to f of p comma q comma r. So u is a function of p, q, and r, and further p, q, and r are functions of three variables x, y, and z, which we have discussed, right? So here we have p, q, r. Here we have x, y, and z. X, y, z are functions of t, r, and s, and here p, q, r are functions of x, y, and z, and u is given by f of p comma q comma r. So now let us write these three expressions in terms of or using these variables, that is p, q, r, and x, y, and z. So now here we have del u over del t. So here we have a u, and here we have t, right? Here we have t. So let us compare these two results. So here we have u, and for t we can take here x. So we can now write here del u over del x, right? Here we have del u over del t. So now in this case, we have to write del u over del x. And similarly, here we have del u over del r. And here we have u, and here we have r. And here we have u, and here we have y. So we have to write the expression for del u over del y, right? And then we have del u over del s. Here we have u, and here we have s, and here we have u, and here we have z. So we have del u over del z. So now we have here a del u over del x, that is del u over del x, and here we have u, and here we have p. So here we can write del u over del p, and then we have del x over del t, that is del x over del t. So here we have del p over del x, right? So comparing these two results, we can easily write expressions for del u over del x, del u over del y, and del u over del z. And then we have del u over del y, that is here we have u, here we have y, and here we have del u over del q, and then we have del y over del t, that is del y over del t. Here we have q, and here we have x. So here we have del q over del x, and then we have del u over del z, that is u over z. Here we have u over r. So we have del u over del r, and then we have del z over del t. Here we have z, here we have t, here we have r, and here we have x. So here we have del r over del x. So now del u over del y can be written as, here we have del u over del x. So here u over x. So here we have u over p, and then here we have x over r. Here we have x over r. So here we have a p over y. So here we have del p over del y, and then we have here del u over del y, that is u over y. Here we have u over q, and then we have here del y over del r, that is y over r. So here we have q over y. So here we have q over y, and then we have del u over del z, u over z. here we have u over r, and then we have here del z over del r, that is z over r. So here we have r over y. So here we have del r over del y. And similarly for del u over del z, here we have u over x, that is u over x. Here we have u over p. So we have del u over del p, and then we have x over s, that is x over s. Here we have p over z, and then we have u over y, that is u over q, and then we have here y over s. So here we have q over z, and then we have u over z. So here we have u over r, and then we have z over s, that is del z over del s. So here we have r over z. So here we have del r over del z. So we have now these three expressions. So now we have to find out the values of del p over del x, del p over del y, and del p over del z. And similarly, we have to find out the value of del q over del x, del q over del y, and del q over del z. And here we have to find the values of del r over del x, del r over del y, and del r over del z. So here we have written all these expressions. So del p over del x is del over del x, and for p we have x minus y. And similarly here we have del over del y of x minus y. Here we have del over del z of x minus y. Similarly here we have for q y minus z, and we have these three expressions: del over del x of y minus z, del over del y of y minus z, del over del z of y minus z. And here for r we have z minus x, so we have del over del x of z minus x, del over del y of z minus x, and del over del z of z minus x. So now here the derivative of x with respect to x is 1, and the derivative of y with respect to x is 0, because here we are finding out the partial derivatives. So the partial derivative of y with respect to x is 0. So here we have 1, and here the derivative, that is the partial derivative of x with respect to y is 0, and the partial derivative of y with respect to y is 1. So here we have minus 1, and then here the partial derivative of x with respect to z is 0. Here also the partial derivative of y with respect to z is 0. So here we have 0. Similarly here we can find out the partial derivatives. So the partial derivative of y with respect to x is 0. Here we have also 0. The partial derivative of z with respect to x is 0. So here we have 0. And here the partial derivative of y with respect to y is 1. Here we have 0. So this is 1. And here the partial derivative of y with respect to z is 0, and the partial derivative of z with respect to z is 1. So here we have minus 1, and here the partial derivative of z with respect to x is 0. Here the partial derivative of x with respect to x is 1. So this is minus 1, and here the partial derivative of z with respect to y is 0, and the partial derivative of x with respect to y is 0. So this is 0, and here the partial derivative of z with respect to z is 1. Here the partial derivative of x with respect to z is 0. So we have 1 minus 0, that is 1. So here we have used the results, that is del over del x of x is equal to 1. Similarly, del over del y of y is 1, and del z over del z is 1. That is, the partial derivative of x with respect to x is 1, partial derivative of y with respect to y is 1, and partial derivative of z with respect to z is 1, and all other derivatives are 0, right? And here it is important to remember that u is a function of p, q, and r, and p, q, and r are further functions of x, y, and z. So now let us substitute these values, the values of these partial derivatives, in these three expressions. So here for del p over del x, we have 1. So here we'll take 1, and del q over del x is 0. So here we have 0, and del r over del x is equal to minus 1, right? And here del p over del y is equal to, here we have minus 1, and del q over del y is equal to 1, and del r over del y is equal to 0, and del p over del z is here 0, and del q over del z is equal to minus 1, and del r over del z is equal to 1, right? So now we can write del u over del x is equal to del u over del p, because del p over del x is 1, and here this term is 0 because del q over del x is 0, and here we have del r over del x as minus 1. So here we have minus del u over del r, right? So let us take this expression as equation 1. And similarly, here we can write del u over del y is equal to, here we have minus del u over del p, because del p over del y is equal to minus 1, and here we have del q over del y as 1. So we have simply del u over del q. This is equation 2, and this term is 0 because del r over del y is equal to 0. And here we have del u over del z, that is this term is 0, del p over del z is 0, and here we have del q over del z as minus 1. So we have minus del u over del q, and here del r over del z is equal to 1. So we have plus del u over del r. So now we have reduced these three equations to these three equations, right? So now we can add these three equations to get the value of this expression. So now adding equation 1, 2, and 3, we have here del u over del x plus del u over del y plus del u over del z, and here we have del u over del p minus del u over del r, and then we have minus del u over del p plus del u over del q, and here we have minus del u over del q plus del u over del r. And from the right hand side we can see that all these terms cancel each other. That is here del u, that is del u over del p is cancelled by this term. Then we have here del u over del r, these two terms get cancelled, and here also del u over del q is cancelled with this term. So here we have 0, and this is our desired result. That is, we have to find the value of this expression. So the value of the expression del u over del x plus del u over del y plus del u over del z is equal to 0 when u is given as f of x minus y, comma y minus z, comma z minus x. So viewers, this is how by the concept of partial differentiation and the concept of total differential coefficient, along with all these results, we can easily solve these type of problems.